So welcome to this video. So in this video we're going to be solving a computation problem. So the problem statement here is basically we have to write an algorithm to check whether a given number n is a happy number or not. So the way we going to be checking whether a number n is a happy number or not is by following these two steps. So we have to start replacing the given number n starting from n with the sum of square of its digits, and we have to repeat it until the number n becomes 1. So which means that, which says that the given number n is a happy number. Otherwise, if we encounter the same number again, it means that we entered a cycle. So in that case, we'll say that the given number n is not a happy number. So basically, our algorithm should check whether the given number n is a happy number or not. If yes, it has to return a boolean true. If not, it has to return false. So let us go through this example to understand the problem statement and better. So in this first example, the input here is n equals to 2. So the 2 becomes 4. It is the sum of digits of in the number 2. 4 becomes 16, and 16, if we do the sum of square of digits 6 and 1, it will become 37. So 37 become 58, 58 become 89, 89 become 145, and eventually it will become 4. So actually over here we are encountering the same number again, 4, as we have encountered before. 2 became 4 at the start, and again we came to 4 again. So over here again 4 will become 16, and 16 become eventually become 20. So this 4 to 20 loop will go on infinitely. So in this case we'll say this 2 is a not happy number. So in the second example, the n is 23. So 23 becomes 13 if we do the sum of square of digits 2 and 3. So 13 becomes 10 and 10 becomes 1. In this case, the number became 1. So we can say that the 23 is a happy number. Yeah. So this is what our algorithm should do, which has to check whether the given number n is a happy number or not. If n becomes 1 after a set of operations, the set of operations is to keep on doing the sum of digits of number. If it becomes 1, if the number given number n is a happy number. If not, if we encounter the same number again, if I enter the cycle, it means that the given number n is not a happy number. Yeah. So we're going to be solving this problem in two approaches. One is a brute force approach, and other is using Gaussian slope pointers algorithm. In brute force approach, basically, first we'll be initializing a empty hash set. So the usage of this hash set is to store the values the number given number n becomes, and then we'll be starting an infinite loop, and inside this infinite loop we'll keep on replacing the number n, given number n, with the sum of square of its digits. And inside the loop we'll be checking if the number is equals to 1. If it is equals to 1, we'll be returning true. If it is not, we'll be checking whether the given the new number n is in the hash set or not. If it is so, it means that we are encountering the same number again. We'll be returning false. If not, we'll be adding this number to this hash set. Yeah, so basically here we are using this hash set to keep a track of the value of number n. It becomes by performing this operation called summing the square of digits of the given number. So and has said keeps a track of it whenever we perform these operation. Perform operation means summing the square of digits, and if it is in the hash set, it means that we have uncovered the same number again. So we'll be returning false, and it is not a happy number. If it is 1, it is a happy number. So this is the idea of this approach one, which is a brute force approach. So this is the computer program of this algorithm. So this is written in Java programming language. So over here, this method called is happy number is the core method of our algorithm. So this basically takes the integer n. So over here, first, as I discussed, I have initialized a hash set of integers, and then I have initialized this, added this integer n to this hash set, and then I'm starting a infinite loop, and in this infinite loop I am replacing n with the sum of square of its digits. And if n is 1, and if n becomes 1, we are returning true. It means that the given number n is a happy number. If not, we are checking whether the n is in the hash set or not. If it is so, it means that we have encoded the same number again, so we have entered a cycle, so we'll be returning false. If not, we'll be adding the n to the hash set. So this is how the computer program looks like for this algorithm, for this brute force algorithm. So now we'll be checking the time complexity of this algorithm. So over here, if we check the first method, we are running this while loop as long as number of times as the number of digits in the given number n. So for any given number n, the number of digits it contain will be in the order of logarithm of n to the base 10. So we can say that this loop will be running in the order of log n. So we can say that the diagonal complexity of this method will be log n. And now if we go to the next method, the method called is happy number. So over here, so the loop will be running this as you are starting an infinite loop, right? So this loop will be running till the number n becomes either becomes one, or if we encounter the same number again. So inside this method, every time we are calling this sum of squared digits. So this method basically has a time complexity of big of log n. So for every loop, we are having a time complexity of big of log n. So the number of iterations before the maximum number of iterations this loop can take is the number of distinct numbers that can be generated by this method called sum of square digits. What I meant by this is, so for suppose if we take this example n equal 23, so before 23 becomes 1, the number of values it generated by this method is 4. So which is the 4 value is nothing, is way less than 23, right? So we can say that for any given number n, the numbers generated by this number before we reach one, or before we encounter the same number again, is much less than the original number. So, for example, typically, if we take the number 999, the number of distinct numbers this method generates before we keep on we encounter the same number is 162. So it generates 162 distinct numbers. So this is the maximum value this number can generate. So we can say that this iteration, the number of iterations of this loop is bounded by an upper limit. We can say it has 162. So putting all together, this first method, sum of square method, has a time complexity of big of log n, and the second method, the number of it is the time complexity will be like number of iterations of this while loop, right? So since it is bounded by a constant, so we can say that the time complexity of this algorithm is big of log n. Yeah. So now, if we check the space complexity, so in the first method, we can say we are not creating populating any data structure, so it is a constant. And in the second method, we can say we are populating this hash set, right? So the hash set will be populated as number of times as the distinct numbers generated by this method called sum of square digits. So typically, if we assume k is the distinct numbers generated by this method, so our hash set will be having the space it will be filled k times. It will be having k integers. Yeah. So the space complexity will be like big O of k. So where k is the distinct numbers generated by this method before which reach the we encounter the same number again. Yeah, so this is the space and time complexity of this brute force algorithm. So now we'll be moving on to the second approach where we use the fast and slow pointers. Yeah. So in this approach, basically we'll be using two pointers named slow and fast. So both will be initialized as number given number n. So the slow will be replaced one step at a time, and the fast pointer will be replaced two steps at a time. So if these both pointers meet at one, then we can say that the given number is a happy number. Otherwise, not. So basically, what we are doing is we are replacing fast pointers two steps at a time. So this we are doing this because to decrease the time taken to verify whether the given number is a happy number or not. So let us understand this with an example. So here, if we take n as 2, rather than replacing 2 one step at a time, if I replace 2 two steps at a time, so 2 will become 16, 16 will become 58, 58 become 145, 145 become 20, and 20 will become 16. So we have verified that 2 is not a happy number in the half time when we are replacing two one step at a time. So when we are replacing two steps at a time, we have decreased the time taken to verify whether the number two is a happy number or not by half. Yeah. So due to so that is the reason why we are replacing the fast pointer two steps at a time. And now we have to while we are replacing it, we have to verify whether the number becomes one or whether we are encountering the same number again or not. To verify whether number becomes one or not, we can directly check whether the fast pointer is pointing to one or not. So that's how we can do that. And to check whether we have encountering the same number again or not, we can't store the values of fast pointer. We can't store it in a hash set as we are doing in first approach and check. So rather than that, we will be using this slow pointer. So if fast and slow pointer, since slow pointer is replaced one step at a time and fast pointer is replaced two steps at a time, this both pointers meet at a it in a value which is not one, then it means that we have encountered the same number again, right? Yeah. So this is how this approach is executed should be implemented. So this is the computer program for this algorithm. So this is basically written in Java programming language. So this is happy number is the main core method of our algorithm, so which takes the integer n as input. So basically here over here we are initializing two pointers, fast and slow, both initialized as n. So over here we are starting a do while loop. So the reason why we are using do while loop instead of while loop is to execute this logic at least one time, even before, even if this condition in the while loop doesn't validate for the first time. Yeah. So that's why we are starting a do while loop, and inside the do while loop we are replacing slow one step at a time, and we are replacing fast two steps at a time. And then we are checking if fast is equals to 1. So if at any point of time the fast pointer is 1, we are be returning true. Our happy point, our number n is a happy number. And at the end we'll be returning false because this loop basically stops when fast is equals to slow. So and if fast is already one, we would have already written true. So it means that fast is not one, and fast and slow met at a point which is not one. So that's why we can say that the number n is not a happy number, and that's why we are returning false. Yeah. So this is how this second approach works. Our second this fast and slow pointers algorithm. So over here, the time complexity of this algorithm will be like big of log n, which is the same as the first approach. So here the first method will have big of log n, and the second method will have the time complexity. So this loop basically will be running as number of times as the distinct number generated by this number. So for any given number n, the number of distinct values this method generates before we encode the same number again or we reach the number one will be much less than the original value. So we can ignore that. So the time complexity will be like big of log n, while space complexity will be like big of 1 because we are not creating any data sets and populating it. Yeah, so this is how the second approach works. So overall, we have seen how to check whether a given number n is a happy number or not. A number n is a happy number if it becomes one after a set of certain operations. The operation here is to sum the square of its digits. If it becomes one, we can say that n is a happy number. If we are encountering the same number again, if we are entering a cycle, then we can say that the given number n is not a happy number and we have to return true. So we have solved this problem using two approaches. One is brute force approach and is fast algorithms approach. So we have seen a decrease in space complexity in these two approaches. So I will leave the link to of the sheet which I am displaying over here in the description of this video so that you can go through this. Yeah, so that's it for this video. See you in the next.